So question 3, the question tells us that we have a triangle KLW and it has a right angle. It has angle L equals 90 degrees. So 90 degrees is a right angle. So we know that it's a right angle triangle. So we can just draw any right angle triangle. It doesn't have to be to scale at all, as long as we put the right numbers in. We're not actually measuring, so we don't need the drawing to be correct. As long as it's a right angle triangle, this is our right angle here. So we know this is angle L because L is the one that's 90 degrees. So we can label that L. And we know that KL, so the question then says KL is 12 meters. So one of these angles is going to be K and the other angle is going to be W. And it doesn't actually matter which one, as long as you fill in the information correctly. So let's just say that this is K up here and this is W here. And now we know from the question, KL has to equal 12 meters. So KL, that's this side here. So now we need to be careful when we fill in the information. This has to be 12 meters. So we can label this 12 meters. So we know that side. And what else does the question tell us? It also tells us that angle W, so angle W, that's this angle here, this angle is 75.2 degrees. So this is our given angle, and they've also given us a side. So when we've got a side and an angle in a right angle triangle, we know that we can use the trigonometric ratios. So it says find KW correct to the nearest meter. So KW is this length here. This is what we need to find. So if we like, we can actually just label that X. You can call it KW if you like. Doesn't really matter, but I like to use one pronumeral, so I'm just going to label that X because I know that's what I want to find. Okay, and now we need to form an equation using the trigonometric ratios. So which ratio can we use? So, Ka or Toa. We're going to need to use one of these equations to help us find X. And if we look at our given angle, this is our given angle here. Which two sides are we working with? We want to find this side and we've been given this side. So these are the sides we're working with. We're not interested in this side at all, so we don't need to worry about that side. And what we've got is, well, this side here, that's directly opposite our given angle. So we're working with our opposite side. And what about X up here? What's this side? The side that we want to find, well, this is the longest side and it's the side that's opposite the right angle. So that's our hypotenuse. So we're working with our opposite side and our hypotenuse, which means we can only really use this ratio here because we don't have the adjacent side, and both of these ratios, they need the adjacent side. So we're not using these. Now, so that's the sine ratio. So this stands for sine of an angle. Sine, we can call the angle theta for now, is equal to opposite over hypotenuse. That's the sine ratio. So we've got an equation there. Now all we need to do is plug our values into this equation. So what's our angle? Have we got an angle? Yeah, we've got a given angle, 75.2. So let's plug that into our equation. Instead of theta, we've got 75.2 degrees. And we can write our equation. What's O? What's our opposite side? Our opposite side is 12. And our hypotenuse, well, we don't actually know our hypotenuse, but we can call it X because that's what we're trying to find. So now we've got an equation and it's only got one unknown. And remember this sine 75.2, that's just going to be some number. So that's as if we had a number on this side. It's not an unknown. We can put it into the calculator and work out what it is. So we just want to find X, at the moment, x is on the bottom of the right-hand side. It's in the denominator. We don't want that, so we need to get it out of the denominator. So I'm just going to multiply both sides by x, because I want x by itself on the left-hand side, so I definitely don't want it over here in the denominator. Sorry, that's not really showing the full solution. Let's fold that. So I'm multiplying both sides by x, which means I'm cancelling out x on this side, and over here I'm left with x times sine 75.2. And on the right hand side, I'm just left with 12. So this is looking a little bit more simple. We've nearly got x isolated over here. We just need to get rid of this sine 75.2, which is multiplied by x at the moment. So the way we get rid of multiplication is division. So we just need to divide both sides by the same thing. These will cancel out. That's why we did it. And on the right hand side, we've just got this expression here, which is 12 divided by sine 75.2. And they're all just numbers. We can work that out on the calculator. 12 over sine 75.2. And that gives me an answer of 12 point, I'm not sure what the question, it says correct to the nearest meter. So it's actually just going to be 12 meters.